Hey everybody, Dustin over at Schematics, and today we have an iPhone 7 Plus that has no home button functionality whatsoever. I did put on a new JC home button and press to go home and all that good stuff worked, but I also took measurement. That tells me that the home button is bad, that's no question. But I took measurements at the board and I saw that I didn't get any power at a certain rail. So I thought this would be a good video, and so I haven't really looked into it much further other than that. Now, I am working from home today, so you may see my dogs running around in the background. Their names are Micro and Chip. Yes, I understand. I'm very much of a nerd. Okay. All right, so let's go ahead and without further ado, let's get started. All right, guys, so before I get started, I want to show you the tool that I'm going to be using. It's called the iBridge. This device is pretty cool because it has all the diode measurements and voltage measurements that the connector should have printed on the tool itself, so it's very easy. You can just run through the connector and make sure everything is looking correct. All right, so we'll go ahead, and I do want to show you the device itself that I'm going to be using so you can kind of see it. You'll see here that it has the diode measurements here, and then also the voltage measurements, 1.8 volts. So you'll see if it has a voltage on the line, it will read here. If it doesn't, it will just have the diode measurement, all right? Now, I did notice here, just as I was taking it out, this little ribbon there is torn. I hope that is not needed because even if it didn't get shipped defective, I'd take my connectors off going this way, and that will tear probably the first or second time that I use this tool. So hopefully that's not going to interfere with us. Alright guys, so while I'm going ahead and putting this tool on the board, I do want to let you guys know why this tool is so fantastic. With diode measurements, you do not need a screen or anything like that connected, okay? But with voltage measurements, you need the device connected. And what I mean by that is if you're checking for voltage on the screen, you need a screen connected and on to get those proper voltages. Same with the camera. Same with any other device that you're having connected to it, okay? So that's one of the reasons that makes this tool vital. So with that being said, let's go ahead and pop this on the board. There we go. And we'll go ahead and take our screw. Well, I guess at this point we don't need our screen. We're going to do diode measurements first, okay? So we'll go ahead and get started on that. We'll switch you guys to the microscope camera. Boop. Turn on multimeter. Alrighty. So we care about the home button, which is this top section up here. So let's go ahead and run through those measurements. Again, you need red probe on ground. Now I'm not going to read out every measurement because now you guys can see. All looking good so far, so maybe we do that tear. Now this one's high, but from what I've noticed, even on a known good device, these two lines are much higher than what ZXW and what this connector says. So I'm not 100% sure why that is, but I have confirmed with a known good on multiple devices to make sure that those are accurate readings, okay? 66. This one doesn't have a measurement there, so we'll go ahead and check in ZXW after we're done with the rest of them. Just remember that that measurement was 543. $1804, and that says, oh well, again, checked with a known good device, that is normal as well. This is not 100% accurate, guys, but you can see how much faster I'm going through these measurements with this tool. This is actually the first time I've used this tool and it's been inaccurate that many times. All right, so that all looks very good there. So the next thing we're going to go ahead and do is we are going to check for voltages. Now, like I said, we do need a screen connected and the device powered on. So we'll go ahead and I'll get that set up and we'll be right back. Okay guys, so diode measurements checked out. I just confirmed with ZXW for that one line that did not have a measurement on the iBridge, and that was about 475, so that was close to what we have, which is very good. The next step is to do the voltage measurements. Now, as I've said in the past, in order to get proper voltage measurements, you need to have the whatever you're testing connected. So if you're testing rear camera voltages, you need to have rear camera connected and the camera app open. Okay, it's the same with the screen and the home button. So I went ahead and connected a known good screen through the iBridge to the board, and we can go ahead and prompt to boot and start taking those measurements. Okay, so let's go ahead and get you guys over to the scope and the DC power supply. We will go ahead and prompt to boot. Prompt. Good to go. Starting the boot. Apple logo. Let's switch this over to volts so we can test that. And we will go ahead and wait for this sucker to turn on. Any day now, iPhone. Waiting on you. I promise it's coming soon. Might just cut this part out. All right, now we're on, so we'll go ahead and take our measurements. All right, so the first measurement we want to make sure we have is 1.8. We have it. Over here we should have 3 volts on these lines, so we should check all 3, and we should have all 3. If we have 1, we do. The next one is the 16 volt line. Ooh, absent. Okay, that line wasn't short in diode mode, so let's go ahead and check the 2.5. Oh no, the screen shut off on me. Come on. 1 second, we're going to just have to short the power button here so it comes back alive. There we go. All right, there we go, the voltage. Let's check the 16V again. And no, we are not there. Okay, make sure. Yeah, we have nothing. All right, so let's go ahead and take a look at some ZXW and schematics. We'll get into schematics a little bit here and kind of show you guys what we're looking at. That is the next step. Okay guys, so now that we have ZXW open, we'll go ahead and jump to the connector and look at the pin that was giving us an issue. All right, so we'll kind of zoom in here, and it was the 4th pin, as I've already got it selected. All right, now if you look here down at net remarks, it will say connector port of fingerprint power 16V0. Okay, so we're having a problem with the home button, and ZXW says this line that we're missing voltage on is for the home button. So more than likely, this is what's going to be our issue. So let's go ahead and jump to the schematic and see if we can figure out more information, okay? So what we're going to do is we're going to find J3801, I believe it was. Yes, okay. Now it was PP16V0, Mesicon, so that means connector. So we'll go ahead and search for that. And it looks like it goes through a filter here. I don't think the filter is going to be the issue, or else I would have gotten weird readings for diode mode, which I did not. And on the other side of the filter, it drops the con part and just is PP16VO MESA. Okay, so we'll do the same thing. We'll drop our con part all the way and follow it to it goes to a test point. And then it goes to U3702, okay? So if we look at U3702, the first line I see here is SW, switch, okay? And that goes to PPVDD main, goes through a coil, and then it jumps to 18 volts, it looks like, all right? Now on PPVDD main, normally we have whatever the battery connector sits, or the battery's voltage sits at. So it could be 4 volts or anything in that area, boost it to 18 volts. All right, so the problem could be this coil here is not boosting properly. We'll take a look at that. Now V in, that makes me think voltage in. All right, that's what that means, and it is directly connected to PPVDD boost. Now this line is required for the phone to turn on, so that is not going to be our issue. We can go ahead and skip that. The next line we have is method to boost enable, okay? And you see en_m, en_s. Those are enable signals, so we do need that for this chip to turn on and work properly. So let's go ahead and search that and see what we get. All right, and it looks like it goes right back to the connector J3801. Okay, so that tells me that the connector is generating this signal. All right, now, unless we don't have a good screen, I have tried a known good screen, we can rule that line out. All right, let's go back to the IC here. Okay. Now, the next thing we have is LDON and then PMID, and it circulates, okay, kind of going back to each other. So I would assume, I'm not an engineer by any means, but I'm thinking that this is kind of equaling out that electricity or soothing out that electricity because it's connected to several caps here. And then the last line we have, other than ground, that those two pins go to ground, the last line that we have here is V out, voltage out. So after this chip does its job and all these things are present, you should get 16 V0 mess on this line here, 16 volts on this line, which we currently do not have. So the first thing I'm going to check is the coil L3703. Make sure I'm getting 18 volts, again, with screen connected and phone on. We'll check that. And then if we have that, I think the next step is going to be just to replace this chip because everything else we should have. Now, let's also check C3709 and C3719. You just have to check one for shorts. Make sure those lines aren't short, and then we'll go ahead and change that IC. All right? All right, guys. So up next, we're going to go ahead and find that IC on the board. So we're going to jump to ZXW. And we are going to look for it. It was U3702, I believe it was. No, maybe not. Error. Sometimes you have to click it twice. It doesn't like to listen the first time. All right, so it says success over here. All right, so this is the little IC that we're talking about now. This was the coil that we were just looking at, U3703. And we will go ahead and these are the two caps on the bottom that we're going to check. So let's check those caps for short. Bring you over to the microscope camera. Okay. It's on the back of the board. Oh, wait, I'll zoom out a little bit. Make sure everybody can see and is in focus. Maybe you're in focus. Okay. All right, so this looks like, now again, we have no power to the device right now, even though things are connected. So we want to check these two caps down here to see if they are shorts. All right, that looks good. That looks good. All right, all that stuff looks good. So this is the IC here that we're going to go ahead and swap out now that everything else looks okay. All right, let's go ahead and see if we can get an orientation on that chip there. Does that chip really have no writing on it at all? Let's see. If it doesn't have any writing, that would be the first time I've seen that. Sometimes it's just harder to read. And a little bit of rubbing alcohol may help read it. Wow, nothing on that no identifying marks at all. So what we're gonna have to do in this instance, guys, is go ahead and just mark the chip. Now this is a donor chip, but we're gonna, or the old IC, but we're gonna go ahead and figure out a way to mark this without damaging it, so we don't have to deal with it in the future. Maybe that will work. All right, guys, so let's go ahead and disconnect all of the things that we do not want connected while we're applying hot air on the board. So what we're about to do is we are going to go ahead and replace that IC and see if we get any other results or different results than what we have. All right, so figure out the best way to do this. Figure out where I want to be applying my hot air. I think I'm going to kind of have it in that direction there. Let me flip this camera over so you can see. All right, turn our heat gun on. We'll set it to whatever temperature you guys feel comfortable using on your workstation. We are going to grab my my lovely favorite tweezers. Make sure we can get in there. Good. All right. No. Okay, now that I've got my camera situated properly, we're going to go ahead and take that IC off. Now, if you see here, I'm kind of heating up a lot of the bottom half of the board. I'm not getting anywhere close yet. Okay, heat that up a little bit. Now I'm going to go ahead and get my tweezers in place. And I'm just going to apply heat, maybe if I can get my tweezers in place. Now this chip shouldn't take terribly long to remove. Right there, very, very easy, as you saw that when it came right off. We'll put that aside just in case this isn't our issue. We can go ahead and put that one back. Let's zoom in here, see if we see anything that we shouldn't. No, everything kind of looks good down there. Now, while I have the IC off the board, I do like to go ahead and take diode measurements of those pads. Let's make sure ZXW has them. And they do. So we will go ahead and take a quick diode measurement on this IC to make sure everything underneath it looks good. It only takes another few minutes to make sure everything is good, because that way if it doesn't work, we don't have to say, oh, now we've got to take the IC back off to confirm that the diode measurements underneath it are okay. So let's go ahead and take those measurements next. So diode measurement time, my favorite part of the day. So this shouldn't take too long. So, all right, they were expecting ground here, ground, good. I think I'm touching something I shouldn't be. Okay, yeah, oh well, that's what we expected. That's what we expect. I know you guys can't see ZXW. Oh well, that's what we expect. And ground, here's what we expect. If we can only touch that. Yep, there we go. Oh well is what we expect down here. That's what we have. And as well as this last one. OL. Perfect, that's what we have. Okay, so those are good. So we'll go ahead and clean up those pads, pull a donor IC, and install it, and hope that it works. All right, guys, so let's go ahead and flux up the board and clean those pads off. Too much flux, but that's okay. Pick up our iron, make sure it's switched to the right one. Oh gosh, all this, come on, oop. Okay, there we go. Alright guys, I think that's good. I don't want any Hershey Kiss type things sticking up. Come on. And then maybe add some solder to my tip here. Maybe that will help us a little bit. There we go. That's getting there. Come on, stop it. There, I think those are all fluffy pillows. Now we'll go ahead and except for this here, which looks like trash, we'll go ahead and clean the flux off the board and see what it looks like. All right, that looks pretty good. Now I don't have my compressed air here, so I'll just have to use my hot air gun to dry off my rubbing alcohol because of impatience. There we go. We'll put client board aside for a second and pull out our donor board.
Now this is where we're going to have to go ahead and mark that IC. It has no indication on which way is up. So we'll go ahead and mark it without destroying it, hopefully, because I've only got the one donor board with me. I think that should be good enough for me to see in the future. All right. And again, we'll bring our hot air back up to temperature. Again, whatever you guys use is dependent on your workstation. Now, since this is donor board, I don't care. I'm not going to heat up all the way around the board. Just going to get my tweezers in. And it's off. And we'll flip her. Oh, look, it does have some indications on it. Just have to hold it a certain way. Okay. Now we go to the reballing of the donor. All right. Again, we'll clean off that mess. You guys, I'm barely touching the IC with my tweezers so I don't nick it, okay? All right, that looks pretty good. Dropping things on the ground. And we'll go ahead and grab our stencil. I really like the Quan Lee gold stencils. These are 3D stencils, which are fantastic in my opinion. What kind of grid we have there? 3x3. This might be the one here then. Make sure that's kind of flush. Let's set our stencil. Nope, that's not going to be it. Look for another one. Here's another one. This may be it here. Yep, this is it here. All right, perfect. See how that fits on there, nice and cleanly. Now we will look for our thermal paste, or not a thermal paste, but our solder paste. We're just going to grab just a tad because this is such a small IC. We don't want to get too much. Put some right on our finger. Okay, and get some tweezers that we don't care about. Put it on, and then you see, even with trying to get not barely any, I still managed to get too much. All right, now we're going to do the same thing, but this time I'm going to use a lot lower air on my stencil. That way I don't bend. And as you'll see, I'm very all the way out here to warm up the stencil overall. Okay, so it doesn't warp on me. Okay, if you warm up that metal instead of just putting it all the heat in one spot at once, it will not warp for you. So now that it's kind of heating up, we'll go ahead and bring it in. And look at that, perfect reball. All right, wait for it to dry a quick seconds. All right, now we'll lift up on the Quan Lee stencil, and that IC wants to be stuck there. So what we'll do is we'll go ahead and take our tweezers and just poke her out. Come on, get out of there. We have better things for you to be doing. Come on. We might need our smaller blue tweezers for this one. There we go. Stop hanging on there. Yeah, that sucker should just fall now. Flip her over, and I guess we'll just grab her off the board. There we go. Awesome sauce, that's what we like to see. Okay, so now the next step is we're going to add a little bit of flux to the IC itself and straighten them balls right up. Beautiful. Beautiful. And again, just clean up the IC one more time. Cool. We can still see the mark that we made on the chip. All right, and we're going to put that up there so we don't lose it. Bring back our client's board. Okay, now we will add just a little bit of flux. Hopefully not too much, because I don't want this IC to start floating away or flying away. As I said, I've only got the one here with me, and I'd hate to drive back to the office to grab a single IC. Okay, there we go. Now we will bring our donor IC back. Baby, come back. You can blame it all on me. Come on, come back on the tweezers. There we go. And our center there in there. All right. I'll line her up a little bit. I'm gonna, come on, maybe we'll line her up a little bit. A little bit more, because I'm anal about this type of thing. I'm just making it worse. All right, we're gonna call that. Let it sit there. We'll go ahead and apply it. Remember, guys, we're gonna keep our hot air up here, away from the IC. Heat up the entire board. You'll see that flux slowly starting to melt away. And we're gonna bring her closer. Now we're gonna wait. You saw how it jumped there, right into position. That's good. That means that sucker's on there. Perfect. Now we'll wait for this to cool, and we will test again, all right? Okay, so I've got the board in the housing, and I'm gonna go ahead and prompt to boot. Now I do have the iBridge plugged in because I wanna take those measurements again, make sure that we have the voltage that we require for this to work properly. So we'll go ahead, I'm gonna flip you over to my multimeter if I can. Boop. Try to get the glare out of you guys' vision there. All right. Now we're just gonna wait for this phone to turn on. Wow, and it turned on a lot faster, so I think we've got this fixed. Cool, so let's go ahead and double check our measurement. 16V, that one. What? Still nothing. That's weird. Hold on, let's put the password in. If it booted a lot faster and then it didn't tell me no touch ID available, but it still has 0 on that. So let's relock the screen. I'm gonna go ahead and try my thumbprint that I see if it'll read. Ah, it does actually. Okay, so it works, but I still don't have voltage there. That's weird. Okay, everybody, so I just used the phone a friend option and talked to a few people to figure out if they can help me understand what just happened. So as I've understand it, that in order to get the 16 volts on that line, it has to be scanning a fingerprint actively, okay? So that's how it works. That's how we learn, guys, but I will show you now
without trying to show this guy's personal information, I have already added my fingerprint, so it does not work to open up the phone or press home, as we kind of knew that wouldn't work already by testing with the JC Home programmer, or home button. But as soon as I have the screen on, I can use my thumb maybe to unlock the device. Okay, so that does tell me that it's working, that we fixed our issue. Guys, still probably going to go with the JC Home button though, so you can have that functionality. But I'm still going to put out this video because I think it's a great way to show you guys how I followed the schematic and how I diagnose these things, and also to show nobody's perfect. You saw I didn't understand, or I didn't know that I needed to be actively scanning a fingerprint for that 16-volt line to show up. Okay, so I'm not sure how I'd even test the scanning and the voltage at the same time. That would have been a pain in the butt. But anyway, as always, I hope you guys enjoyed and learned something today.